Alright, hello everyone. We are going to do the aerosol can for VnTP tables. So hopefully you've written down a table that looks like this. V is volume, N is number of particles, T is temp, and P is pressure. And then we have our initial, final, and effect. So this is actually a situation that can happen. It's why there's a warning on your paint cans. So it says on a hot 350K degree day, so that's our initial temperature, and I'm just telling you what the Fahrenheit would be so that you have some number sense of what's going on here. Remember, we have to be in Kelvin because temperature, you can't have zero, like if you have a 0 temperature for Celsius or a negative temperature for Celsius, that's not going to show particle movement, and temperature is all about particle movement, so you have to be in Kelvin because Kelvin is the only scale that has a 0 for particle movement. So it says on a hot 305K summer day, you go to the hardware store and you buy spray paint to paint some chairs. The spray paint is initially at a pressure of 10.2 atm. So we're going to put 10.2 atm here, and remember there's lots of different pressure units. We're always going to use atm or millimeters of mercury or torr, I think is what we decided. When you get home, you decide to wait until night when it is cooler to paint the chairs, and you leave the cans in your car. The temperature in the car becomes 344 Kelvin, so 160 Fahrenheit, which your car can get even hotter than that. The cans explode in your car. This is the worry when you have spray paint. You can't get it too hot. What is the pressure? So we want to know what this guy is. When, right before the can explodes, because obviously whatever this pressure is what comes to this temperature. It does not say anything about volume. In fact, the spray can is a non-flexible container, right? You can't expand this. This is an X. And then we have not used the spray can. We have not diminished the number of particles, right? So also, there is no number of particles on this one. So we want to know what our effect is. Here from our initial to final, temp is going up, right? Initial, final, temp is going up. And so we want to know if temperature goes up, what is pressure going to do? Okay, what is pressure going to do? And some of you might be saying, oh, Ms. Osterberg, it goes up, it goes up. That is correct, but we need to draw a little picture to prove that. So our volume's the same, so our box has to be the same size that we're going to draw. So this is the same size box. This is me trying to draw the same size box. Same size box. So that means volume's the same. We need the same number of particles, right? So we're going to do, we'll do 4. 4 particles in each box. So this is our initial, and this is our final. We always have to draw a picture. We're going to have to draw a picture on the worksheet still. So we know that temperature is increasing, right? So our initial is at a lower temp than our final. So our initial is going to have the small arrows, and our final is going to have the large arrows. So if temp increases, which one's going to have higher pressure? Well, the final, because obviously these are going up. These are hitting the sides of the wall harder because they're at a higher temperature. They're going faster. So pressure is also going to go up. So pressure goes up. So now we do the math for this. So now what we're going to do is we're going to start with the 10.2 atm. And we want pressure to go up. Pressure needs to go up. So the way we do this is we're just going to make this math, this fraction, 305 over 344, or 344 over 305. We're just going to make it either make us have a bigger number or smaller number. We want our equal to be bigger. So we are going to put the bigger number on top, 344K over 305K. And that allows us, if we do 10.2 times 344 and then divide by 305, we get 11.5 ATM, which is bigger than 10.5. So if temperature goes up, pressure also goes up. Now let me just show you, if you would have done it the other way, if you would have done 10.2 and you would have had 305 over 344, so 305, oops, let me do this, times 305 divided by 344, you would have seen that temperature went down. Pressure went down. It would have been 9.04. So you should have known that that's not true. Okay, that's not true. So like what I was doing here is you take 10.2 ATM. If you take it 305 over 344, like this, you would have gotten 9.04 ATM. And that can't happen because this means that as temperature goes, if temperature goes up, we're saying, right, is temperature going up from initial to final, you saw that the pressure went down, and that's not the case. That's not what our picture is showing us. So this one is not, oops, let me fix that a little bit. Sorry about that. This one is not true. This one cannot be true. So if you want this number to get bigger in the answer, the bigger number has to go on top. If you want this answer to get smaller, the smaller number goes on top. But in this case, because we want, if temperature goes up, pressure goes up, we see that here, as temperature goes up, pressure goes up, these are hitting the sides of the wall harder, more often, then this one has to be true. Pressure is going up. This one cannot be true.